So, hello friends. Today I am talking about LS coupling. My name is Mohammed Tirtaj K. So, what is LS coupling? LS coupling is also known as Russell-Saunders coupling. It's a quantum mechanic approach to describe the energy of electrons in an atom or ion. It's a coupling scheme that describes how the orbital angular momenta of electrons are combined to form the total electronic orbital angular momentum of the atom. So, what is coupling? Coupling is the act of combining two things. They are mechanical elements that couples two drive elements which enables motion to be transferred from one element to another. In example, in order to transmit a torque between two shafts that either tend to lie in the same line or slightly misaligned, a coupling is used. So, coupling in physics, two systems are coupled if they are interacting with each other. They are there are two types of coupling, LS coupling and JJ coupling. So what is LS coupling? LS coupling or Russell-Saunders coupling predicts result in good agreement with the observed spectral details for many light atoms. In such cases of multi-electrons atoms, the spin-orbit coupling is weak. In this coupling scheme, it is presumed that the orbital angular momenta of the individual electrons add to form a resultant orbital angular momentum L. Similarly, the individual spin angular momenta should couple to produce a resultant spin angular momentum S. Then L and S combine to form the total angular momentum. This scheme of coupling may be visualized in terms of a vector model of angular momentum J is equal to L plus S. So, orbit-orbit interaction. Consider orbital motion of two electrons L1 and L2 are their quantum numbers. L1 star h by 2 pi and L2 star are their angular momenta. L1 star and L2 star are quantized with respect to each other in such a way that they form resultant L star, where L star is equal to L into L plus 1 whole raised to 1 by 2, and L is equal to 0 to 0, 1, 2, 3, etc. for SPDF etc. Consider an electron in the p orbit and other in the d orbit. Here, two vectors L1 star is equal to root 2 and L2 star is equal to root 6 V6 may um, orient themselves in any one of three positions. L star is equal to root 2 V2 V6 and V12 corresponding to L is equal to 1, 2, 3 or PDF terms. All negative values of L from L2 minus L1 to L plus L2 plus L1 are allowed. Next is spin-spin interaction. With the two electrons each having a spin angular momentum of S star h by 2 pi, where S star is equal to S into S plus 1 all raised to 1 by 2 and S is equal to 1 by 2. There are two ways in which a spin resultants S star h by 2 pi may be formed. S1 and S2 are spin quantum numbers of two electrons. This implies S1 star is equal to 1 by 2 V3 and S2 star is equal to 1 by 2 V3. The two resultant quantum numbers are S is equal to 0 and S is equal to 1. S is equal to 0 gives rise to singlet and S is equal to 1 to reciprocity. Quantum numbers. The principal quantum number n describes the sizes of orbitals. The angular quantum number describes the shape of orbital. The magnetic quantum number describes the orientation in space of particular orbit, and the spin quantum number describes the spin. The angular momentum L is equal to summation over Li and S is equal to summation over Si. The momentum L and S then interact via the spin orbit effect to form the total angular momentum J. This scheme is called LS coupling. The momenta L and S combine to form the total angular momentum J as J is equal to L plus S. The angular momentum magnitude L, S, J and their Z components LZ, SZ and JZ are all quantized in the usual ways with the respective quantum numbers L, S, J, ML, MS and MJ. Both the L and ML are always integers or zero, while the other quantum numbers are half integral if an odd number of electrons is involved and integral or zero if an even number of electrons is involved. When L is greater than S, J can have 2s plus 1 values, and when L is lesser than S, J can have 2L plus 1 values. Atomic nuclei also have intrinsic angular momenta and magnetic moment S, and these contribute to the total atomic angular momenta and magnetic moments. Such contributions are small because nuclear magnetic moments are 10 raised to minus 3, the magnitude of electrons moments. They lead to the hyperfine structures of spectral line with the typical spacing between components of 10 raised to minus 3 nm as compared with the typical fine structures spacing 100 times greater. So term symbol orbital angular momentum states are customarily described by a lowercase letter with the s corresponding to L is equal to 0, P2, L is equal to 1, D2, L is equal to 2, and so on. A similar scheme using capital letters is used to design the entire electronic state of an atom according to its total orbital angular momentum quantum number L as follows: L is equal to 0, 1, 2, 3, 4, etc. as PDF, as SPDF, GHI, etc. To drive the term symbol for the different spin orbit states, we first need to calculate the total orbital angular momentum and the total spin from those of the individual electrons respectively. Then L and S are combined to find the total angular momentum of this group of electrons. J. The possible combinations for L, S and J are given as following. L is equal to 11 minus 12 to 11 plus 12. S is equal to S minus S2 to S plus S2. J is equal to L minus S and L plus S. Next, when two orbital angular momentum having quantum numbers 1 and 12 combine, the allowed values of L are L is equal to 11 plus 12, 11 plus 12 minus 1 to 11 minus 12. Similarly, the allowed values are calculated for S and J. For a given value of L, the allowed values of J are J is equal to J L plus S, L plus S minus 1, L minus S 2 L minus S. For L is greater than S, there are 2S plus 1 values of J, and for L is smaller than S, the number of possible values of J are 2L plus 1. The values of 2s plus 1 is called the multiplicity of the state. When s is equal to 0, we have 2s plus 1 is equal to 1. Such states are referred to as singlet state. When s is equal to 1 by 2 and 2s plus 1 is equal to 2, these are referred to as doublet states. When s is equal to 1 and 2s plus 1 is equal to 3, they are referred to as triplet states. So LS coupling in selection rule. For selection rule for LS coupling, delta S is equal to 0, delta S is equal to 0 to 0 or 1 or plus or minus 1, delta J is equal to 0 or plus or minus 1. However, the J is equal to 0 to J is equal to 0 transition is forbidden. Delta M is equal to 0 plus or minus 1. However, the M is equal to 0 to M is equal to 0 is forbidden if delta J is equal to 0. Thank you.